2 weeks ago, I blood tested for the 8th time in 2024. And note that this is test number 56 since 2015. So with that in mind, what's my biological age? That's what we'll see here. This is using Dr. Morgan Levine's biological age calculator, PhenoAge. And if you have blood test data and you want to calculate your own biological age using this test, there's a free downloadable link in the video's description. All right, so when entering these data, I get a biological age of 34.7 years, which is 17.2 years younger than my chronological of 51.9 years. So note that the maximum reduction for biological age relative to chronological age using this test is about 20 years. So 17 years is a pretty good result. But this is just one test, and I'm more interested in tracking year-to-year change. So with that in mind, let's take a look at biological age results since 2018, as I have 37 tests over that period. And that's what we'll see here. So in 2018 to 2019, I have data for 3 tests. Average PhenoAge was 36.1 years. But 3 tests over a 2-year span probably isn't representative of full year averages. So with that in mind, I started testing more often, 6 times each in 2020 and 2021. And average biological age using PhenoAge was 35.6 years in each year. So this is probably a closer representation to a full year average relative to 3 tests over a 2-year span. So then I increased the testing frequency to 7 tests in 2022 with an average PhenoAge of 33.8 years, my best year to date. It got a bit worse in 2023, again over 7 tests to 34.7 years. And after all 8 tests in 2024, average PhenoAge was 34.8 years, about the same as last year. So at worst, we can see that I've avoided an age-related biological age increase. And inherent in that measurement is that even if all the biomarkers stay the same, the 9 biomarkers that are contained in this test, PhenoAge increases by 0.9 years per year of chronological age. In other words, starting from 2020, where I had 6 tests, again, probably a closer representation to a full year average relative to 3 tests over that 2-year span, 2018 to 2019. 0.9 years times 4 years after 2020 would be 3.6 years added on to 35.6, which is 39.2 years expected biological age in 2024. But it's 34.8 years for that 8-test average. In other words, I've been able to improve biomarkers over the past 4+ years. Now, rather than just looking at data entered into a spreadsheet, which anybody can do, let's take a look at screenshots of the lab report and do a deep dive. So that's what we'll see here. This is page 1 of 3. And note that to generate these data, I don't go to my doctor 8 times a year, which would be a nightmare, and trying to convince them, at least historically it's been a nightmare. I go to ultalabtest.com, I pick exactly the test that I want, I print out the form for all the tests, I bring that to Quest Diagnostics, pay the $9 blood draw fee, and then I get the results relatively quickly. Here we can see that I tested around 7:30 in the morning and had most of these results, I think except for 4 biomarkers, CRP, homocysteine, Lipoprotein A, and I think Candida IgG. But the rest of these biomarkers were ready 15 hours later. So if you test yourself, if you're into blood testing like me and you'd want to help support the channel, there's an affiliate link in the video's description. All right, on to some highlights and lowlights, or room for improvement. So first, HDL at 64 is close to that optimal range in men for 50 to 60, and that's based on all-cause mortality risk. And I have videos on the channel, so if you missed that, I would just do a search for HDL and check it out. So the importance of this 64 in my case is that it's now 13 tests in a row where HDL is greater than or equal to 50 milligrams per deciliter, with an average HDL over that period of 56. Now that's potentially important, not only because it's in that optimal range finally, but for the previous 43 tests that go back to 2015, average HDL was 45 milligrams per deciliter. So I've been able to improve it over time. And just taking a look at those 2 averages doesn't really tell the full story. I've had HDL values as low as 28. So we can more than double our biomarkers, at least in this case. And I've done that by following correlations with diet and other metrics, which have led me to the higher, chronically higher now 13 tests in a row for HDL. Similarly, hsCRP at 0.2 milligrams per liter is now 21 tests in a row where I'm at the lab's detection limit, so 0.3 milligrams per liter or less. And note that it's easy to just say, okay, well, 21 tests in a row, this is pretty good. I don't have to measure anything else for inflammation. But hsCRP is just one pro-inflammatory measure or one measure of inflammation. Two others, as I've indicated here, are TNF alpha and IL-6. And these are important because they are produced by senescent cells, which, as I'm sure we all know, senescent cells increase during aging. So for the next test in January, coming up in a few weeks, I'll be measuring TNF alpha, IL-6, and hsCRP. And I may actually include TNF alpha and IL-6 for every test going forward with the goal of keeping them relatively low for as long as I can with the goal of slowing aging, at least slowing inflammaging. All right, and then on to some weak spots. Homocysteine at 10.7 micromolar is a weak spot. And you can see that it's lower than the reference range, which is less than 11.4. But based on all-cause mortality data, values closer to 5 may be optimal. Now, this isn't a genetic issue. I've had values around 5 to 6, around 20 years ago. So homocysteine is definitely a weak spot. And then I'm sure there will be many in the comments that are saying TMG, supplement with trimethylglycine. I've done that experiment, 4 grams of TMG per day. That link is actually on my blog, michaelusgarten.com. So if you're interested in seeing that story, check it out. But it didn't make a dent, unfortunately, on my homocysteine. I've also tried high-dose serine plus B6, high-dose methylfolate in B6, glycine. B12 does work by about 10%, but it may mess up other biomarkers. So I've strayed from that approach for now. Now, for the next test, though, I'm going to try something else, and that's N-acetylcysteine, which in at least 2 studies has been shown to reduce homocysteine. So I'm starting with a relatively low dose, 1 to 1.5 grams per day. I started that on December 24th, so I'll have around 3 weeks before testing to see if it'll make a dent on homocysteine. All right, on to page 2. Glucose went in the wrong direction from 90 on the last test to 95, and that's now just outside the optimal range of 80 to 94 based on all-cause mortality risk. Now, to put glucose into further perspective, my 54 test average since 2015 is about 90 milligrams per deciliter. So we can see that 95 is definitely going in the wrong direction. Now, note that HbA1c may be a better measure of long-term glucose levels. And it's been a while since I included that in the approach, actually October of 2023 when it was a relatively low 5.1%. So for the January test, I'll include HbA1c, and actually I'm going to include that for every test going forward, as I think we should be measuring both glucose and HbA1c as an integrated approach for metabolic health. So we'll see where my HbA1c levels are in a few weeks. Onto the kidney function markers, creatinine at 0.87 is good news because my 56 test average since 2015 is 0.95 milligrams per deciliter. Creatinine levels increase during aging up to a point, and I'll have more on that in a second, but that it's 0.87 lower than my average is good news relative to the aging data. Now, on the other hand, at very old ages, creatinine may not be a good measure of kidney function, and that's because of 2 competing variables that are going on. Kidney function declines during aging, which leads to an increase in creatinine, but on the other hand, creatinine is proportional to muscle mass, which declines during aging, thereby leading to less creatinine in the blood. So at older ages, particularly over 65, creatinine may not be a good measure of kidney function. And with that in mind, I've measured cystatin C in the past, which may be a better measure. That too will be on the January test. But even without that, for now, there are other measures that we can use to get an indirect assessment of kidney function, including blood urea nitrogen, which increases during aging, in part because kidney function declines during aging and the kidneys become less good at removing urea from the blood. So when considering that blood urea nitrogen increases during aging, that it's 8, which is relatively low, this is potentially good news. And for those of you who are serious, hardcore biochemistry nerds like me and into the biomarkers and have studied the all-cause mortality data, a blood urea nitrogen of 8 milligrams per deciliter is actually associated with an increased all-cause mortality risk. So how do you square that circle where BUN increases during aging, so lower is generally better, but not too low? Well, at advanced older ages, liver function declines and urea is produced in the liver. So the rationale for having very low levels of blood urea nitrogen being associated with an increased all-cause mortality risk is likely linked with liver dysfunction. And we'll take a look at my liver function markers in a minute to see if that BUN is actually related to youth or potentially liver dysfunction. And then a third marker that can be used as an indirect assessment of kidney function is uric acid. And we can see that the lab flagged it as low, but I covered in a couple of videos ago why I'm not worried about that. Particularly because uric acid levels increase during aging, and in terms of all-cause mortality risk, 3.6 milligrams per deciliter is close to lowest risk. So I'm not worried about the reference range flagging that as low. So when considering that uric acid levels increase as kidney function declines, and that it's on the lower side, at least of my range, this suggests good kidney function, because if kidney function was suboptimal, I'd expect higher levels of uric acid. So collectively, these three markers suggest that kidney function is youthful and not suboptimal. But let's take a look at those liver function markers. And before we go there, as a quick shout out, if you're into the biomarkers, I've got a biomarker specific tier coming on Patreon that'll cover what's optimal based on aging data, published aging data, and all-cause mortality data for 27 biomarkers. And that's just the start. It's going to be a whole tier dedicated just to what's optimal for biomarkers. So if you're interested in that, check it out on Patreon, coming very soon. So in terms of the liver function biomarkers, I could start with albumin and alkaline phosphatase, which are relatively youthful and optimal based on all-cause mortality risk. But a more specific measure, or what's thought to be a more specific measure of liver health and function, is AST and ALT, aspartate and alanine aminotransferases. So it's optimal for those two liver-specific, or they're mostly found in the liver enzymes, are values in the high teens, low 20s. So we can see that in both cases, I'm pretty close to low 20s, so good news there. But both of these enzymes can be tricky because their all-cause mortality associations follow a J-shaped curve. In other words, too low is suboptimal. Optimal is, again, in the high teens, low 20s, and then as the values increase from the high teens, low 20s into high 20s and 30s, all-cause mortality risk increases. So with that in mind, defining what's associated with all-cause mortality risk in terms of how low is too low, even though somewhere in the 15 range for both enzymes is suboptimal, a more direct measure may be GGT, gamma glutamyl transferase. And that's in part for two reasons. One is that there are studies that show it's more strongly associated with liver disease mortality relative to AST and ALT. And two is that it's pretty close to linearly associated with all-cause mortality risk, with low levels being better and higher levels being higher risk, easier to interpret and a potentially better marker in terms of liver disease mortality. So in my case, GGT is on the lower side. So liver health and function seems to be close to optimal and youthful, which argues that blood urea nitrogen being 8 milligrams per deciliter is not related to liver dysfunction, which then collectively brings it back to it being a marker of good kidney function, and that if kidney function was suboptimal, blood urea nitrogen would be higher, but that's not what we see. So anyway, moving on. So what I'd like to highlight next are globulins, and this is probably a dramatically underrated aspect of biomarker tracking. So globulins refers to immunoglobulins, but this isn't just one specific protein. This is a mix of many different proteins. For example, one of them includes alpha A1 antitrypsin. And if you saw the aging by autodigestion video on the channel a few weeks ago, that could be a good marker of protein digestive enzymes leaking into the blood and alpha 1 antitrypsin being elevated to help counteract that. I may measure that coming up very soon, so stay tuned for that video. But why I'm interested in the globulins is more specifically because of immunoglobulin G, which comprises the majority of the globulin fraction, around 44% in my case. So immunoglobulin G increases during aging. In a recent study, and I'm trying to get the authors of that study on the channel to present their data. If they don't come on the channel, I'll present that data likely at some point in a video on my own. But immunoglobulin G increases during aging, in interventions that are known to improve health span and lifespan, specifically exercise training and calorie restriction, lead to lower levels of IgG in the blood. Additionally, in that paper, when they experimentally reduced IgG levels in blood, it extended median lifespan. So IgG is now on my radar. I'm going to include it for every test going forward, probably forever. Now, I can't say what's optimal in terms of 1,056. What I'm planning on doing is, although there is some published data on how it changes during aging, the actual number, what may be optimal, may be variable depending on inflammatory status and a whole bunch of other factors. So what I plan on doing is tracking it with every test and then looking at correlations for IgG with my other biomarkers to see an actual value for what may be optimal. Is it 800? Is it 600? Is it around 1050, which is what we have here? So stay tuned for that story. That'll probably be coming, over the next 2 years as I collect data, 16 tests or so, to start making those videos on IgG. I'm also tracking thyroid hormone function. For those who are familiar with the channel, I was diagnosed with hypothyroidism in my 20s, so I've been taking levothyroxine for most of my life. And actually, thyroid hormones, specifically inactive thyroid hormone T4 and the active thyroid hormone T3, may be two of my biggest weak spots of all my biomarkers. So T4 is actually aged. If you look at how T4 changes during aging, this is what you'd expect to find someone of an older chronological age. And my T3 levels are also aged. Again, you'd more likely to be found at older ages relative to younger ages. So with that in mind, when looking at the free T3 to free T4 ratio, and that's important because free T4 is converted into free T3. And during aging, that conversion worsens. So in my case, that ratio is 0.18, which is actually what is more likely to be found in 90-year-olds relative to someone of my current chronological age, around 52. So I'm working out the recipe, if I can, based on correlations with both FT3 and FT4 to see if I can improve them. I only have, I think, 6 or 7 tests. So I'm not convinced that I can actually improve them, considering that my thyroid gland has atrophied, or at least it was in my 20s, and I don't imagine it's gotten any better. I may have to bite the bullet on this one and just switch my approach from supplementing with T4, being prescribed T4, to taking specifically T3 if my conversion can't be improved. Also note that lipoprotein A was flagged, and this isn't unusual. Lipoprotein A, generally in my case, is almost always flagged as being outside of the reference range. How far outside of the reference range is another story. Now, a few things about lipoprotein A. One is that it's thought to be resistant to any type of dietary or supplemental or even prescription med changes. So with that in mind, I've had values, and I think I have more than 30 tests going back to 2015. I've had values as high as 145 nanomolar. So 80 nanomolar is a big improvement relative to 145. So this idea that lipoprotein A can't be improved or modified is false. And I'm not taking any specific drugs or prescription meds to try to alter that. And even more recently, for the last test, for the October test, it was 90 nanomolar. Now it's 80 nanomolar, and that's by tweaking stuff in my diet. And I've got the correlations for lipoprotein A on the correlations tier on Patreon. So if you're interested in that, check it out. But taking this a step further for lipoprotein A is that it contains apoB. So when lipoprotein A is high, one would expect a relatively high apoB and correspondingly high cardiovascular disease risk. So in my case, at least for the October test with that lipoprotein A when it was 90 nanomolar, apoB was relatively low at 68 milligrams per deciliter. Now, I didn't measure apoB for this test, but it will be on the next test. So we'll see where that stands with a relatively lower lipoprotein A. All right, on to page 3, highlighting first hemoglobin. At 15.1 is now back to close to youthful status in my case. And that's potentially important because hemoglobin levels decline during aging. And I started to see that pattern, at least a small amount, in 2024 over those 8 tests with an average hemoglobin of 14.8, which is different relative to my 53 test average since 2015 of 15.1. Now, this might not seem like a big change, but I think this is how aging starts. Maybe 2024, average hemoglobin is 14.8, and then 14.7 the year after, and then so on for about a decade. Now I'm looking at average values of 14. So when I see even small decrements, I try to intervene based on the correlations with diet and any supplements that I'm taking to try to get back to youthful values, if I can, as quickly as possible. All right, another potential weak spot is the MCV. This is the average red blood cell volume, which increases during aging, with lower values being more likely found in youth. And when considering that it increases during aging, bigger red blood cells are found at older ages. So in my case, 93.1 is not the lower end of my range. The lower end of my range is somewhere around 89. So this is a current weak spot. I've had values that are recently higher, so I've had some progress in bringing it down from around 95. Now, why I'm not too worried about that, though, is that I'd be more worried if the RDW, which is a measure of the standard deviation of the average red blood cell volume. In other words, do you have lots of small red blood cells, a mix of small, medium, and large red blood cells, or lots of large red blood cells? That variability is the RDW. So the RDW also increases during aging. So if the MCV was high and the RDW was high, I'd be more worried. But that the RDW is youthful and associated with a low all-cause mortality risk based on its current level of 11.7, I'm not too worried about the MCV, at least for now. Neutrophils, 1778. If you look at what's optimal in terms of all-cause mortality risk, that's 2,000 to 3,000. So in my case, 1778 would be an increased all-cause mortality risk. But again, I'm interested in looking at year-to-year change. So for over the 8 tests in 2024, average neutrophils were 1972. Now granted, that's just outside that 2,000 or 3,000 range, but when considering that neutrophils are pro-inflammatory, closer to 2,000 is probably more optimal relative to closer to 3,000. So I'm happy to be around 17, 1800, as long as it's not something, 15, 13, then maybe I'd work on trying to increase it by a bit. I don't want to have too many immune cells to fight off potential microbes, right? And that could be one of the consequences of having too low for neutrophils, monocytes, or lymphocytes. DHEA sulfate declines during aging, and in my own data, going back about 20 years, I've had values that are much higher than this, around 300 micrograms per deciliter. Now, unfortunately, I also supplemented with DHEA back then, so I don't know what my baseline values were in youth. And I don't know if DHEA is the reason why I had values around 300. So 128 is relatively low relative to where my data was. And knowing that it declines during aging, it could be a weak spot. But if there is good news to that story, my 18-test DHEA sulfate average, which spans the past 28 months, is 125. So at least for this test, I'm pretty close to my average over the past 2+ years and resisted any age-related decline over that period. If I can resist any further age-related decline or potential further age-related decline, because again, I don't know what DHEA sulfate was in my youth, but if my values are 128 for the next 50 years and I avoid that age-related decline, for me that's a win because I've resisted an age-related change. Granted, I'd like to have it higher, but how high is also debatable. And then last but not least, Candida IgG, which is a subdivision of total immunoglobulins that I showed on the last page. This too has been elevated or just outside the reference range for all of the tests, 7 tests in 2024. What it indicates is that my immune system has to produce antibodies to help keep Candida somewhere in my body in check. Now, I'd prefer to have lower values, and I'm working on, following the correlations with diet. And that's one reason that I used rapamycin to try to bring down Candida IgG, but it didn't make a dent. Whether I can make a dent by diet and moving stuff around, I'm not sure, but stay tuned for that story as I'll be tracking this for every test going forward. All right, so the next step in this journey is what's the diet and supplement approach that are associated with this 17-year younger biological age. And I'm working on that video. I hope to get it out by Wednesday, if not next Sunday. All right, that's all for now. If you're interested in more of my attempts to biohack aging, check us out on Patreon, where I offer blood test consults, and I've got that What's Optimal for Biomarkers tier coming very soon. Before you go, we've got a whole bunch of discount and affiliate links and other things that you can use to help support the channel while also working on testing yourself or using things that can be used in an approach for optimal health. And they include ultralabtest.com, which is where I get the majority of my blood tests, Clearly Filter's water filter, which I have in my house and I use every day, at-home metabolomics, oral microbiome composition testing, NAD testing with Ginfinity, epigenetic testing, at-home blood testing with Cyfox Health, which includes apoB, but also GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or diet tracking brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. Hope that you enjoyed the video. Have a great day.